Hello everyone, this is Kruti Patel from Pharmaceutical Technology Department, LJ Institute of Pharmacy. Welcome to Pharma Ignite, the official channel of LJ Institute of Pharmacy. In last session, we had studied about microencapsulation. In that we had covered different methods about microencapsulation. Today we are going to continue with those methods only, the remaining methods only. Let's have quick revision. Which were the different methods for the microencapsulation. If you look at the methods, then there are mainly 6 methods of microencapsulation. The first is air suspension method. The second is coacervation phase separation method. The third is pan coating. The fourth is multi-orifice centrifugal force. The next is solvent evaporation method, and the last is spray drying and spray congealing method. In last session we had studied about multi-orifice centrifugal force, also the air suspension method and the pan coating. Today we are going to learn about remaining methods. Let's start with the first technique. The first technique is coacervation phase separation. Now it is made up of 2 words here. First is coacervation and second is phase separation. Now we all know about phase separation. What is phase separation? Phase separation means separation of phases. Okay. Now the new word is coacervation. Now what is coacervation? Coacervation means separation of colloidal phase from lyophilic soil by addition of any other substance or by addition or by changing condition. Okay, now here again it is a bit complicated, right? So let me simple it down. Your colloid rich phase or colloidal lyophilic phase means we are talking about polymer. Okay, polymer will be dissolved. If we look at the actual process of microencapsulation, then we have to dissolve coating polymer in a specific solvent. Okay, and mostly the solvent will be lyophilic in most of the cases. Okay, in most of the cases. Now this solvent, what we have to do, from this solvent we have to separate out colloidal phase. We have to separate out our polymer phase. That is known as coacervation. Okay, so coacervation phase separation means we are going to separate out polymer layer and then we are going to formulate microcapsules. Okay, so that is coacervation phase separation. Once we go into detail, this method will be getting more clear. Okay, one more thing, this method is very important. It is a bit complicated but also it is very much asked in your exam, and also at the same time it is the widely used method for the formulation or manufacturing of microcapsules. Okay, so let's learn them or understand them very clearly. So yes, if we look at the steps of coacervation phase separation, then there are 3 steps. First is formation of 3 immiscible phases. Second is deposition of coating layer, and third is rigidization. These are the 3 phases. Okay. First is formation of 3 immiscible phases. What is this formation of 3 immiscible phases? That we will be learning afterwards. But let's understand these 2 terms first. Second part is deposition of coating layer. Okay. Now what happens? You have your core material, right? Once you are done with that first step, separation of 3 immiscible phases and all, then what happens? That deposition. Suppose this is a coating material. So around that molecules has to come around them, and there should be deposition of that molecules. Okay, and that should form a continuous film. That is the case. In the third step, what we have to do, this outer part, this coating part will be in liquid form still. Okay, when it gets deposited, it will be in liquid state. So what we have to do, we have to solidify them, we have to rigidize them. Okay, and then only they will be converted into free flowing solid particles. So yes, this rigidization is mainly taken place by changing temperature or by cross-linking polymers or by desolvation method. Let's move to first step. What is the first step? Let's see them. So formation of 3 immiscible phases. Now before starting this, let's understand how microcapsules are formulated actually. Okay, so first, as I have shown here, there is a beaker. In that beaker there is a solution of coating polymer, right? And what is being done, the core particles are being added in that. Okay, So what happens, you have a beaker, in that you have a polymer. In that polymer you have to add solvent. Okay, solvent for the polymer, that means there should be a solution of polymer. Then we will be applying different conditions, so microcapsules will form, and then we have to go for rigidization. This is the basic step. Okay, now let's start with the formation of 3 immiscible phases. Now this 3 immiscible phases means which 3 immiscible phases, that we need to understand. Okay, so 3 immiscible phases means, first, which I have written, is a liquid manufacturing vehicle phase. Bit complicated, right? First is liquid manufacturing vehicle phase, the second is a core material phase, and the third is coating material phase. Okay, these 3 are the base. These 3 are the phases, 3 immiscible phases. Okay, how these 3 phases are formed? Now, the first step is we have to prepare these 3 phases, right? That means one is your core phase, that is fixed. The second is your coating phase, in which we are talking about our coating material, right? And third phase is liquid manufacturing vehicle phase. That means we have to separate out our coating material from the solution. Okay, if we separate out coating material, then the remaining liquid will be known as liquid manufacturing vehicle phase. Okay, now we saw that 3 phases are formed like this, right? Now one more term is there, immiscible. Now what does this immiscible word says? Immiscible phase means core material, coating material, and liquid manufacturing vehicle. These 3 phases should be immiscible in each other. Okay, formation of 3 immiscible phases is known as coacervation. Okay, now how this coacervation is carried out? Then if we look at the content, then this 3 immiscible phases can be carried out by 5 different techniques. Okay, either you change temperature, that is temperature change or thermal change. The second is by addition of incompatible polymer. The third is by addition of non-solvent. The fourth is by salt addition. The fifth one is by polymer-polymer interaction. Now to understand these different methods, we need to remember that phase diagram. Okay, phase diagram is very essential to understand all these phases. According to phase diagram, as temperature decreases, the system becomes from 2 phases to 3 phases. That means all phases will be separated out, and that forms the coating around the core material. Now the second one is incompatible polymer addition. Okay, incompatible polymer addition. Now how this works? Say for example, I have 2 polymers, polymer X and polymer Y. Okay, and I have a solvent. Now my main polymer is polymer X. Okay, I want to coat my core particles with this X polymer. Now I am dissolving this X polymer in a solvent, right? So what happens there? That forms a solution. Now what I have to do? I have to create 3 immiscible phases. Okay, so now what I will be doing? I will be adding this Y polymer in that solution. So when I add this Y polymer, what happens? This Y polymer is soluble in my solvent, right? But the problem is this X and Y, they both are incompatible. They both cannot stay together. They have a problem, okay? So they cannot stay together. And what happens? The solvent will be having more affinity for Y rather than X. So what happens? Initially there was solution of X and solvent, they are forming solution. Then there enters polymer Y. So when there enters polymer Y, what happens? This solvent will leave polymer X. Okay, this solvent will leave polymer X and that will go to polymer Y. Okay, so what happened? This polymer Y became alone, and that will go and form coat around core material. So interesting and so easy, right? This theory, incompatible polymer, is very familiar, I guess, right? Okay, so that is addition of incompatible polymer. Now let's start with the third one. The third one is non-solvent addition. Okay, now this non-solvent addition is kind of similar to that incompatible polymer. Okay, now what happens? I have a solution, I have a coating polymer, I have a solvent. I'm adding that coating solution in that solvent, a coating polymer, sorry, in that solvent, and then I'm forming a solution. Okay, now what I have to do, I have to add a solvent which is non-solvent for this polymer. Okay, in that polymer was added, now in this case solvent is added. Okay, so when I add this solvent in this solution, what happens? This polymer is incompatible or is not soluble in that solvent. So what happens? That polymer will come out, which is very much similar to your precipitation technique. Okay, so this polymer will come out and that will form a coat around that particle. Okay, now the next method is salt addition. Now when I am using water soluble polymer and my that liquid phase will also be water soluble, then in that cases if I add inorganic salts, soluble inorganic salts, then what happens? My coating polymer will precipitate out and that will be forming a coat around that. Okay, so again this is very easy, it is just like precipitating out. And the last technique is polymer-polymer interaction. Okay, now what is this polymer-polymer interaction? Now if I want to go for polymer-polymer interaction, then I have to use polyelectrolytes. Now what are these polyelectrolytes? Polyelectrolytes, let's catch words. Polyelectrolytes, there are two words. First is poly and second is electrolytes. Polyelectrolytes means polymers which have characteristics of both polymers as well as electrolytes. Now what is electrolytes? Electrolytes means at specific pH they will be converted into cations and anions. Okay, so they are the electrolytes. Now this polymers will be acting as polyelectrolytes. Then what happens? One polymer will be positively charged, we have to add another polymer, that another polymer will be negatively charged, they both will combine and then they will be forming immiscible phases. Okay, so that is known as polymer-polymer interaction. So these are the different techniques to separate out our polymer from its solution. Okay, if you employ these techniques, then what happens? Coating polymer will separate out from the solution and that will go to our core material and that will be forming microcapsules. Okay, let's move further. The second technique is solvent evaporation technique. Okay, now solvent evaporation, as name suggests, what we will be doing? We will be evaporating our solvent and then forming microcapsules. Now in case of this solvent evaporation technique, what happens? You have to take your coating material. Now that coating material is dissolved in some volatile solvent. Okay, coating material is dissolved in what? In volatile solvent. Okay, then we have to take another beaker, a big beaker, in which we have to take our core material and in that we have to add one liquid manufacturing vehicle phase. We need some phase in which this microencapsulation takes place, right? That core material can either be dissolved or it can be dispersed. It can be anything. Either it can be dissolved or it can be dispersed. Okay. So yes, there is a big beaker, there is a small beaker. See, here you can see a difference. So that will be easier for you to understand. So that coating polymer is added into core solution with constant stirring. With constant agitation, you have to add that. Once you add that, what you have to do? You have to increase temperature. When you increase temperature, that volatile solvent will evaporate, right? When that volatile solvent evaporates, your coating polymer will form coat around core material. Once that is done, then we have to go for rigidization and then we can have either microcapsules or microspheres. Okay, when we get microcapsules, when our core material is dispersed in liquid manufacturing vehicle phase, then we will be having microcapsules. That means that will be forming reservoir type of system. And if our core material is dissolved in liquid manufacturing vehicle phase, then what happens? That will be forming matrix type of system. And when that forms matrix type of system, that is known as microspheres. The last technique which is remaining is spray drying and spray congealing. Okay, the spray drying, again, you have already studied in your pharmaceutical engineering, right? What happens in that? Your particles which you want to dry were sprayed in hot air stream, and they will be forming and they will be getting dried. Okay, same principle is applied in case of coating solution, in that you have to add your core material, then you have to spray it, small particles will form, and those particles you have to go for drying, or you have to go for rigidization, and that will give you microencapsulations. Okay, now till now it is very easy. Now, but I have written two words. First is but I have written two words. The first is spray drying and the second is spray congealing, right? Now, what is the drying and what is congealing? Let's understand spray drying first. Spray drying means I will be using solvent. Okay, let's move to another part, spray congealing. Now, congealing means solidification by reducing temperature, in simple terms, right? So spray congealing, that means the polymers which we will be using, that will be in molten form. Okay, they at room temperature they will be in solid state, but when you increase temperature, what happens? They are getting converted into liquid form. Same thing we have to do, we have to melt them. We have to melt our polymer. Once we melt them, we have to add our core material in that. Okay, so that is forming molten mass. Then that molten mass or that liquid mass is sprayed. What happens when we spray them? We can reduce temperature. In spray drying, we have to apply temperature, we have to increase temperature so that materials get dry. Whereas in case of spray congealing, we have to reduce temperature. So what happens when we reduce temperature? Your coating part will get solidified. Okay, and you will be getting your product. This is the first case. In second case, what you can do? You can directly spray those particles in a non-solvent. When you spray them in non-solvent, what happens? They will be quickly rigidized, and then you can separate out them from. You can separate those particles by either by evaporation or by simple filtration through that non-solvent, and you can have your product. Okay. So with this, we complete all the methods of our manufacturing of microcapsules as well as microspheres. I guess it was easy, right? And also we are completing the chapter microencapsulation. Let's look at the questions which are being asked. If you want to study this chapter in depth, you can also refer Industrial Pharmacy by Leon Lachman, or you can refer Alton. I hope microencapsulation is clear to everyone. For more such videos, please subscribe Pharma Ignite. Thank you so much.